Okay, Assalamualaikum and hi everyone. Today, I would like to discuss about the tutorial for 6.3 Le Chatelier principle. Right, for question number 1 here, you can find out the answer from the notes. Okay, question number 2. Okay, consider the following equilibrium system. Alright, so this is the equation, and you have to refer to this. Given to you, delta H value is negative 1531. Determine which direction, okay, with the direction shift to re-establish equilibrium if the system is disturbed by adding O2, removing NH3, and increasing the temperature. So, direction, okay. Alright, so first of all, okay, adding O2. So, when adding O2, okay, the concentration of O2 will increase. Okay, so the system will try to reduce, okay, the concentration of O2. But how to reduce? So therefore, ammonia will react with oxygen gas to produce more N2 and H2O. Alright, so the equilibrium direction will shift to the, okay, in order to reduce the concentration O2. Okay, so next what would happen? Therefore, the concentration of N2 increase, concentration H2O also increase. However, concentration NH3, it will decrease, as well as concentration of O2 also decrease. Alright, next, number 2, removing NH3, which means this will affect the concentration of ammonia decrease. The system try to increase the concentration of NH3, but how? So that's why it will shift to the left. Shift to the left. Okay. So therefore, what will happen? Concentration NH3 increase. Concentration O2 also increase. However, concentration N2 will decrease, as well as concentration H2O also decrease. Okay, number 3, increasing the temperature. Okay, so therefore system will absorb heat. Absorb heat. We refer to this delta H value. So this negative value, which means the forward reaction is azo and the reverse reaction is endo. Okay, so when temperature increase, so system will try to absorb the excess of heat. Absorb. So that's why the system favor endothermic reaction. Okay, because of that, equilibrium position will shift to the left. Okay, what will happen next? So the concentration of NH3 will increase, as well as O2. Okay, however, the concentration of the products decrease. Okay, now we move to the question number 3. Okay, decomposition of ethane produce ethene and hydrogen gas. Alright, and given to you the clue here, delta H here is positive. By using Le Chatelier principle, alright, explain the shift in equilibrium position if any of direction. If first, the concentration of hydrogen gas is decreased. Okay, right. Okay, alright. So when the concentration of H2 gas is decreased, so H2 decrease, so system try to increase. Okay, so that's why it shift to the right. Okay, in order to increase the concentration of H2. Okay, next, when the temperature is lowered, T is lowered. So system try to increase heat. So increase heat. Okay, so we refer to the delta H value here is positive, which means forward reaction is endo. Reverse reaction is azo. So increase heat, which means release heat lah, by release heat. So release heat, which means the reaction favor exothermic. So therefore, the reaction will proceed to the left. Okay, next, number C, a catalyst is added. Catalyst is added. So therefore, there is no change in equilibrium position because the function of catalyst is to speed up the reaction. Okay, alright. So next, number D, C2H6 is removed from the system. So therefore, C2H6 concentration will decrease. So system shift to the left in order to form more C2H6. Okay, next, the volume of the container is increased. So remember, P total equals to N total RT over volume. So when volume of the container is increased, right? So therefore, the total pressure will decrease. Okay, P total decrease. The system will increase the pressure. So it will increase the total pressure here by shift to the side that has greater number of mole. Okay, so meaning that it will shift to the greater number of mole. So at the right hand side we have 1 mole. Product side we have 1 plus 1, 2 mole. So therefore for E, it will shift to the right. Shift to the right. Okay, pressure is increased. When pressure increase, remember P total and total RT over volume. When pressure is increased, alright, so the volume will decrease. Kan? By decreasing the volume, so system will try to reduce the total pressure, reduce the total pressure, so it will shift to the side that is less number of mole. So meaning that it will shift to the left. Okay, shift to the left for F. Alright, next, inert gas is added at constant pressure. Okay, at constant pressure. Okay, so meaning that when constant pressure here, so the P total remain constant. Okay, so therefore, the partial pressure for each gas, okay, which means partial pressure C2H6, okay, partial pressure of P total, okay, partial pressure for C2, okay, C2H4 and partial pressure for H2. Okay, each one of this, it will decrease. So in order to increase the pressure, so it will shift to the side that has greater number of mole. So it will shift to the right. Okay, and then inert gas is added at constant volume. Alright, so still the volume constant. So partial pressure for each of gases here is remain constant. So therefore, no change in equilibrium position. Okay, one more last question here. Okay, so nitrogen for the oxide dimerized as follows. Okay, so given to you the value of delta H is equal to negative. Alright, so based on Chatelier principle, explain how the product could be increased. Target here, product increase. So meaning that the system is always shift to the right side. Okay, in order to increase the concentration of N2O4. Right, so we move to the first here is refer to the concentration. So in terms of concentration, okay, so we want the equilibrium always shift to the right. So therefore, what we can do, so we can reduce or decrease the concentration of N2O4. Okay, 1. Okay, and then we can increase the concentration of the reactant. So these two, it will shift the direction of the equilibrium to the right side. Okay, next, in terms of temperature. Okay, in terms of temperature, so we look at the delta H value here is negative. So meaning that the forward reaction is azo. Okay, the reverse reaction is endo. So meaning that the system should undergo exothermic in order to remain shift to the right. Okay, so therefore we have to decrease the temperature. Okay, what would happen? So system try to apa? To increase heat or increase heat by release heat. Yeah, release heat. So release heat. So it will favor exothermic. Okay, that's why it shift to the right. Okay, next in terms of pressure volume. Okay, pressure or volume. Okay, we refer to the number of mole. So at the reactant side, we have 2 mole. Product side, we have 1 mole. So because of that, so we can increase the pressure. Increase pressure. So system will try to reduce pressure. Okay, it will shift to the side that is less number of moles. Okay, that's why it shift to the right. So that's all for today. Thank you and Assalamualaikum.